Right then, let's get stuck into a concept that could genuinely reshape our future, the circular economy. Now, this is a massive part of your A-level environmental science spec, and my goal here is to make sure that by the end of this, you've got the key principles absolutely nailed.
So, here's the plan. We're going to start by properly diagnosing the problem we're facing, our linear economy. Then, we'll look to the ultimate expert, nature, for some inspiration. From there, we'll break down the core principles of a circular economy, see how it all works in the real world, and then zoom out to understand why this is so important on a global scale.
First things first, we really need to get our heads around the system we're currently stuck in. It's called the linear economy, but you can think of it in much simpler terms. It's the take, make, dispose model.
And this really shows you the difference, crystal clear. On the left, you've got our current model. It's a one-way street, isn't it? From resource to rubbish. We take materials from the earth, we make something, we use it, and then we just throw it away. But the circular model on the right, well, that changes everything. It's not a straight line, it's a loop. It's all about designing waste out of the system right from the very beginning.
So, if our current system is so broken, where on earth do we look for a better one? Well, the answer has actually been staring us in the face for billions of years. Let's see what we can learn from nature's own perfectly sustainable systems. Okay, so this should be a bit of a recap for you from your studies. Biogeochemical cycles are basically the planet's engine room. They are these incredible, intricate systems that constantly use and reuse essential elements like carbon and nitrogen, moving them between living things and the non-living environment.
And the key takeaway from all of this is that nature is all about balance. Just think about the carbon cycle for a second. The amount of CO2 that's released by all the organisms respiring is perfectly balanced by the amount that's sucked up by plants during photosynthesis. This creates what we call a dynamic equilibrium, a stable, self-regulating system that can just keep going indefinitely.
Now, this is where we see a really huge difference. In nature, there is no such thing as waste. It just doesn't exist as a concept. When a leaf falls from a tree, that's not waste. That's future nutrients for the soil. But in our human systems, well, our waste isn't a resource. Too often, it's toxic, it's not biodegradable, and it just builds up, causing pollution. So by looking really closely at these unbelievably efficient natural systems, we can start to pull out a set of core principles that we can use to build our own circular economy. We're basically trying to apply nature's logic to the way we live and work.
And here they are, those core principles inspired by nature. It all starts with the really big ideas, right? Cycling materials over and over again, empowering the whole thing with renewable energy, just like ecosystems do. Then it drills down into a whole new way of thinking about design. We've got to separate our biological materials from our technical ones, build diverse, resilient systems, and make sure that the waste from one industry becomes the raw material for another. And maybe most importantly, we have to design products with their end of life in mind from the very first sketch.
And here's a key exam term that wraps all of this up beautifully: cradle-to-cradle design. It's the complete opposite of the old cradle-to-grave approach. Instead of a product's life ending in a landfill, its components are specifically designed to become the raw materials for something brand new. So the end of one product's life is literally the beginning of another's.
Right. That's the theory. But how does this stuff actually work in practice? Let's take a look at how these principles are being applied in different sectors to help create more sustainable lifestyles.
Let's kick off with waste management. In a circular economy, the real goal isn't just to get better at recycling waste. The ultimate goal is to eliminate the very concept of waste altogether. And a huge piece of that puzzle is separating materials right at the source, in our homes and businesses.
And if you look at these typical collection schemes, you can see just how vital that separation is. When things like paper, glass, and plastics are all kept separate, they don't get contaminated by each other. This means the materials stay high quality, so they can actually be turned back into valuable new products. If we don't all play our part in this, the whole system just doesn't work.
Next up, mineral supplies. Our linear model means we are constantly digging up new virgin materials, which, as you know, is incredibly damaging to the environment. Circular thinking completely flips this. It forces us to find really clever ways to get value from stuff we've already thrown away or from resources we previously thought were too low grade to bother with. Bioleaching is a brilliant example of this. It's basically using biology to do our mining for us. We can use specific microbes, like this acidothiobacillus bacteria, which naturally produce acids that dissolve metals out of low-grade ores. This means we can extract valuable resources like copper without the huge environmental cost of conventional mining. It's incredible, really.
Okay, what about food production? Applying circular principles here means a major shift in thinking, away from just chasing maximum yield like we see in industrial farming, towards the much smarter goal of optimum production in a more integrated, natural system. Take fish farming, aquaculture, for instance. The old way was all about maximum yield, which often led to loads of pollution and disease. The new circular goal is optimum production. That means using smart tech, like CCTV cameras to stop overfeeding, and having lower stocking densities. But it also means using really clever systems like integrated multitrophic aquaculture, or IMTA. This is essentially creating a mini ecosystem where the waste from one species, like fish, becomes food for another, like seaweed or mussels. You see, it's all about working with nature, not against it.
And finally, let's touch on pollution control. The traditional way of doing things is to deal with pollution after we've created it. This is what we call an end-of-pipe solution. A circular approach says that's not good enough. It tries to stop the pollution from ever being created in the first place.
This quote just sums up that massive shift in thinking perfectly. It's all about fundamental changes to the design. So instead of just slapping a catalytic converter on a petrol car to treat the exhaust fumes, you change the technology completely to something like a hydrogen fuel cell, where the only thing that comes out is water. It's being proactive, not reactive.
So let's zoom out. Why is this move to a circular economy so incredibly urgent on a global scale? To answer that, we need to understand the critical balance between two key ideas: our planet's biocapacity and our own ecological footprint.
The easiest way to think about this is like a bank account for planet Earth. Biocapacity is the interest the planet generates each year. It's everything it can regenerate and all the waste it can absorb. Our ecological footprint, on the other hand, is how much we're spending each year. And the scary part is, for decades now, our footprint has been way bigger than the planet's biocapacity. We're spending the capital, not just the interest. A circular economy is one of our best strategies for shrinking our spending and finally getting our global budget back into balance.
And that leaves us with the big question, the one for your exams, but also for our future. Thinking about everything we've just covered, from cradle-to-cradle design and bioleaching to sustainable aquaculture, how can all these circular strategies actually help us shrink our ecological footprint and learn to live sustainably within the limits of our amazing planet?